Okay, wanted to do a quick support video on Module 2 Assignment 1. And share this screen because my work's happening in Excel. Okay, first question is actually measures of central tendency. It says find the mean median mode from a frequency table. I'm going to take this data, copy it, paste it, change the row column sizes, maybe add some borders here just to kind of make it easy to see. All right, so got some 9s, I got some 8s, I got some 7s, I got some 11s. I have no idea what this data is about. No problem. I can do some calculations here. Mean, median, mode are my goals. This would be very easy if I had a list of data. I have 11 9s. 9, 9, 9, 9. Okay. You may be tempted to do that, and there may be a reason to do that in some situation, but it's not necessary to do it here. First thing I want to do, though, is to just redo this in order, because for median, it's going to be helpful to see things in order. So to do that without having to destroy the table that I'm working on, I'm just going to copy and paste a new one. There's 10 7s. There are 5 8s. There are 11 9s. And there are 3 11s. I really don't like the fact that there's repeated numbers here. It makes it very confusing. Okay, so now I don't need this table anymore. I can leave it there. So mean. For the mean, basically, if I have 10 7s, that's going to be a total of 70. And so I'm going to do this multiplication step. Then I'm going to add everything up. And then I'm going to divide by how many there are. And how many there are is the sum of the frequency. And so my mean here would be 242 divided by 29. Okay, the median is going to be the number in the middle. Now there's 10 7s. Well, first of all, there's 29 numbers. If there's 29 numbers, what's the number in the middle? It's going to be the 15th number, if I'm not mistaken. How do I do that? Well, let's say I've got 5 numbers. 5, 8, 9, 5, 8, 9, 10, 12. By the way, I'm using a similar problem-solving approach where I'm just kind of convincing myself that I know how to find the middle number. There are 5 numbers here, and the middle number is the third number, which is 5 plus 1 divided by 2. So if I have an odd number, I can take the middle of that a couple of ways. I could just do 5 divided by 2 and then round up, or I could just add 1. 5 plus 1 is 6. 6 divided by 2 is 3. And that should always work. Just do one more with 7 numbers to kind of prove to myself that I'm not crazy. One, two, three, four, five, six, 7 numbers. And so 7 numbers, 7 plus 1 divided by 2, that gives me 8 divided by 2 is 4. The fourth number, 1, 2, 3, 4, should be the middle number. That's this one. Got 3 numbers on the right. I got 3 numbers on the left. Okay, good. So that's why I said 15. 15 is right. 29 plus 1 is 30. 30 divided by 2 is 15. So the 15th number is what I'm looking for. And it looks like the 15th number, I've got 10 7s, and I've got 5 8s. So the 15th number would be an 8. And I could use a cell reference if I want, linking it back to here. And then the mode is the most frequent, and so that is going to be the 9 because there are 11 of those. So these are all sort of in the center. They're measures of the center, and they're different ways of saying what the center is, what's typical. It's a good way to think about that. Okay. Let's move on to the percentiles and quartiles. What I would recommend is highlighting the data, copying it and pasting it over here. If you paste it into G, you'll be able to see the whole width of data, and then you can start typing it out. 18, 21, 22, 25, 26, 27, 29, 30, 31, 32, 35, 37, 41, 42, 47, 52, 55, 57, 58, 62. I'm going to double check by counting. But I don't need to count because it says in the problem there's 20 ages. So I'm just going to highlight this and look at the count. 20, good. Feel relatively good about that. 50th percentile, percentile.exe. And then I highlight the data I want to look at. And then I put in 0.5 or 50%. And it gives me the number that is the 50th percentile. This is actually the median. So if I type median and do this, I should get the same answer. And that'll be comforting. Notice that if there's 20 numbers, that means there's 2 numbers in the middle. And that's why I'm getting a number for the median 50th percentile. That is not actually in my data set. It's the average or the mean of these 2 numbers in the center. Same thing for 70th percentile. Again, you got a lot of numbers here, so just be patient, get the numbers in. You can double check with somebody else to make sure you're on the same page. And now I want to do the 5-number summary and the box plot. So I'm actually going to use a different data table here, and I'm going to make my life a little bit easier by reducing the number of values. There's 3 9s, there's 2 8s, there's 4 7s, and there's 1 11. Okay, so this would be pretty easy to write out. 9 9 9, 8 8, 7 7 7 7, and 11. And your job is to make your 5-number summary: min, Q1, median, Q3, max. We have formulas for all of these. Min is min. Q1 is the 25th percentile, percentile.exe. Highlight the data, put in 0.25. Oh, shoot. This isn't going to be very interesting. Let me back up. Give myself a couple more data points. 2, 3, 15, 26. Okay. Let's try again. So forget about this. Okay, so equals min. I'm finding the minimum value. I'm finding the 25th percentile. I don't know what just happened with help over here, but I don't need it. I'm finding the median. I can do the 50th percentile if I wanted. And I'm doing the 3rd quartile. That is the 75th percentile. And then I'm doing the max. Okay, so that's my 5-number summary. And then the next thing you want to do is to actually do a little box plot. Now, you could do this by hand with a little ruler, but come on, we're in the 21st century here. So I gave you a link. I'm going to go ahead and bring it up over here. And bring it over here. Okay. So when you click on the link, it'll take you here. You don't have to log in or sign up. It's just the Desmos calculator. And you can see you've got the data there. I'm going to actually change the size of this so that I can type these numbers in. This is a little bit long-handed because I got to actually type numbers into this data set. So I'm just going to start going here. 9, 9, 9, 8, 8, 7, 7, 7, 7, 11, 2, 3, 15, 26. There we go. And there is my box plot. So now I'm going to take a little screenshot here. And I'm going to take that and I'm going to paste it directly in to here. So there, I've done my 5-number summary and I've done my box plot. I think that takes you for the second one that you're doing, you're going to do it from a frequency table. But again, I did show you that where you just take the data in the frequency table and actually just make a list. This is not a very big data set, so that's not super annoying. It's a little bit harder, not hard to find the min and the max, but it's harder to find the percentiles if you don't actually have the data listed out. So it's going to be easier to just do that. Last thing I want to look at is the definition of the interquartile range and the outlier. So first of all, IQR can be calculated from just doing Q3 minus Q1. Okay, so my interquartile range is just Q3 minus Q1, and then 2.5. And then the next part is basically I'm saying I'm going to define an outlier as below 1.5 IQRs. Sorry, let me just say this. 1.5 IQRs below Q1 or 1.5 IQRs above Q3. So basically I'm saying, I mean, first of all, 26 should feel like an outlier because it's pretty far away from the rest of the numbers. But on that hand, 15 might also be an outlier. So that's what we're trying to define sort of mathematically, like how do we know whether a data point is an outlier or not? For that matter, 2 and 3 might be outliers because the main body, remember, was all of the data from sort of 7 to 11. And then all of a sudden there were these weird numbers here that I typed in at the end to make it more interesting, to make our box plot more interesting. So let's do the math here. What is 1.5 IQRs? So I do 1.5 times my 2.5. And then I'm going to go below my Q1. So equals Q1 minus my 1.5 IQRs. So this is my cutoff. In other words, anything below 3.25 would be considered an outlier. So based on that definition, both of these points are actually outliers. And we might construct the box plot to look differently in terms of shortening the whiskers up to the 3.25 and then making little kind of star marks out here to show these are outliers. We'll see that sometimes. 1.5 QRs above Q3. Well, I already know what 1.5 QRs is, but I'll just do it again for fun. And then I'm going to add on equals this plus 1.5 IQRs. And so we're at 13.25. So the 11 is not an outlier. Anything above 13.25 would be considered an outlier. So basically, the last 4 numbers that I just threw into the data set are outliers because they're significantly different than the rest of the data, which is captured in this range here. And that's what we're trying to show with these IQR calculations. Okay, hope that helped. It's a pretty challenging assignment, so don't worry if you need help, but just make sure you're reaching out and asking for help and for clarification. Keep in mind that you want to sort of keep both tasks or goals in mind, which is to complete the assignment, but also to understand what's happening here. All right.